This is a GCSE physics presentation looking at specific latent heat. To get started, there are 4 questions relating to specific heat capacity, which is covered in another presentation. If you haven't seen that already, you may want to go back and have a watch through that. But there are 4 questions that you should be able to answer based around specific heat capacity. Pause the presentation, go through your answers, and when you're ready, restart the presentation and check how you've done. So pause now. Well, the definition of specific heat capacity is the amount of energy needed to increase the temperature of 1 kilogram of a substance by 1 degree. The equation is mass times specific heat capacity times temperature change, and that'll give you the energy involved. We've got the standard unit for specific heat capacity is joules per kilogram per degree Celsius. And how many grams are there in a kilogram? Well, there are 1,000. Anything that has the word kilo in it is 1,000. So 1 kilogram is 1,000 grams. In this session, we're going to define the term specific latent heat. We're going to look at latent heat of fusion and latent heat of vaporization. What's the difference between those? And then we're going to go on to do some interpretation of heat and cooling graphs, and finally some calculations linking specific latent heat, mass, and energy change. Get started. Here's a question. A student measured the temperature of their ice cream for 30 minutes and they found it was always at 5 degrees. Why did their ice cream melt if it didn't increase in temperature and the room temperature was 20 degrees Celsius? Spend 1 minute, pause the presentation and spend 1 minute and try and come up with an answer. When you're ready, you can restart. Well, the reason is that heat energy from the room is increasing the thermal energy inside the particles of the ice cream. But the particles are rearranging themselves to move from a solid to a liquid. And because the energy is being used to rearrange the particles from a solid to a liquid, it means that there is no energy available to change the temperature, so the temperature of the substance remains constant. Only when it has changed the state of matter will we then start to see change in temperature again. When we talk about internal energy, remember we're talking about the internal energy found in particles that make up every single thing in the entire universe. There are 2 types of energy that make up the internal energy of particles. Do you know what they are? Well, the 2 types of energy are kinetic energy and potential energy. And when we say the internal energy of a particle, that is what we're referring to. When we heat up particles, remember when we heat up, we are adding thermal energy and we cause a change in the arrangement of particles when we change their state of matter. If we are not changing the state of matter, then we are causing a change in the temperature. Name the processes involved in changing a substance from a gas to a liquid, and then from a liquid to a solid. Well, from gas to liquid is known as condensing, and from liquid to solid, the process is known as freezing. When it comes to specific latent heat, the definition of specific latent heat is the amount of energy absorbed or released to change the state of matter of 1 kilogram of a substance without changing temperature. And that's extremely important when it comes to interpreting graphs. The temperature is constant when we're talking about specific latent heat. It's the internal energy of the particles that changes, resulting in a change in the state of matter, but there is no change in temperature. So which line in the graph represents the specific latent heat? Well, we're looking for where there's no change in temperature, which means it is B. So on B, the line is constant, horizontal, temperature doesn't change. Therefore, at B, we have a change in the state of matter. We do talk about specific types of latent heat, and what we can talk about is the latent heat of fusion when we're going from solids to liquids, or latent heat of vaporization when going from liquids to gases. And of course, vapor is easy to remember with gas. On the graph, where would we find the latent heat of fusion and the latent heat of vaporization? Pause for a second, work it out, come back, check your answer. Pause now. Well, what you have is the latent heat of fusion is where we go from a solid to a liquid, which means we are looking at point B, whereas the latent heat of vaporization is where we're moving from a liquid to a gas, hence we're talking about part B. Remember, there is no temperature change when we're talking about changes in states of matter, so we're looking for the horizontal bits of the graph. When it comes to heating substances up, you can see that this graph, we are heating up, we're increasing the temperature. And we start off with a solid, turned into a liquid, and turned into a gas. What is the point, and the term point is important, represented by B and C, and what is the point represented by D and E in terms of temperature? Well, B and C is the melting point, and D and E is the boiling point, because they are the temperatures at which we change from one state of matter to another. On a cooling curve, we talk about two different points, but when we're talking about cooling, we're talking about reverse processes. So we're talking about freezing and we're talking about condensing. On the graph, name the points represented by B and C and D and E, remembering they're horizontal and there's no temperature change. So the points must be the condensing point and the freezing point because we are cooling rather than heating. Now, specific heat capacity and specific latent heat, people very easily get them confused and overlap. Remember, in heat capacity, specific heat capacity, we're talking about changes in temperature, whereas in specific latent heat, we're talking about a constant temperature, but a change in the physical state of the substance. What are the units for specific heat capacity and for specific latent heat? Well, specific heat capacity is joules per kilogram per degree Celsius, and specific latent heat is just joules per kilogram. There's no temperature change, so we take the degrees Celsius out of the units. There is a specific equation you need to use with specific latent heat, and it's the energy for the change in state is equal to the mass multiplied by the specific latent heat. This equation is given to you in the AQA exam, but I'd suggest that you memorize it anyway. When it comes to equations, don't forget in the exam they may ask you to rearrange the equation, regardless of which way you memorize it, and you should be using what I refer to as a SMRF, simple method for understanding and rearranging formula, in order to be able to memorize all the different variations of an equation. You put in the different variables into the triangle with the top line divided by the bottom line and the bottom line times each other. Then all you have to do is put your finger over the thing you want to work out. So for example, if you put your finger over the L, we need to get E divided by M. If we want to calculate M, it's E divided by L. And if you want to calculate E, it's M multiplied by L. The actual method you use in the exam to rearrange equations is not important as long as you can rearrange them correctly. What you've got here is two examples of the type of calculation you may be asked in an exam question. Pause the presentation, have a go at both calculations, the equations given to you in the top right corner, and when you're ready you can restart the presentation. Well, in the first question, it says calculate the energy needed to change 15 kilograms of a substance from a solid to a liquid with a latent heat of fusion of 12 joules per kilogram. Well, all we have to do there is a simple multiplication, which would give us 180 joules. Remember, if you leave the units off your answer, it can cost you marks. In the second question, we are given a latent heat of vaporization, and again, it's a simple calculation, but we have to do a little rearranging because it gives us the energy and it gives us the latent heat of vaporization and asks us to work out the mass. Well, if we rearrange the triangle, the Smurf, you will find that you have to get the energy divided by the latent heat of vaporization, which gives you a mass of 9 kilograms. Just be aware in the exam setting, they could make this a little bit more tricky by giving you a table with latent heat of fusions and latent heat of vaporizations for different substances and expect you to look up the table to find the correct number to put into the calculation. So make sure you know the difference between the latent heat of vaporization and the latent heat of fusion. Just to finish off, there are a number of statements and all you have to do is for each one identify if it's true or false. Pause the presentation, go through each of the statements, and when you're ready, you can restart the presentation to check your answers. So pause now. Well, the answers are as follows. The symbol for mass is not a capital M, it's a lowercase m. Remember, temperature is measured in degrees. No, it's not. It's measured in degrees Celsius. You could use degree Fahrenheit, but it's not normally something we do in the UK. It's degrees Celsius. Latent heat of vaporization is when we get liquid turning into gas. Well, that's true because remember the vapor. Specific heat capacity involves change in temperature is true. The freezing point is the temperature where we get a liquid turned into solid is true. Potential and kinetic energy of a particle is its internal energy is also true. Specific latent heat has a constant temperature is true. The equation for specific latent heat is mass times energy change is false. It's mass times the specific latent heat is the energy change. Particles are more spread out in a gas than a solid is true. And the units for specific latent heat is joules per kilogram per degree Celsius is false because we should not have the degree Celsius there. It's just joules per kilogram.